Assalamu alaikum everyone, how is it going? This is Ahmad from Code Culture. In today's video, we're going to be going over channels in Go. What are they, how we can use them, and what are the tricks that we should pay attention to when working with them. So before we start, I just want to say that you can find links to the diagrams and the source code used in this video in the description down below. This video is divided into two parts. The first part is dedicated to explaining what is a channel in Go and how we can use it. The second part is going to be dedicated to solving interview questions and explaining the answers and pointing out the possible mistakes. So without further ado, let's get started. So first of all, we need to understand what is a channel in Go. For this, we're going to be using the following illustration diagram. As you can see, a channel in Go is just a queue, to be more exact, a FIFO queue, where the first elements being added to the queue are going to be the first one processed. In Go, there are two types of channels. The first type is unbuffered channel, and the second type is buffer channel. An unbuffered channel means that no sender can send a message unless there's a receiver on the other side waiting to process it. While a buffer channel allows you to send some messages, store them inside the channel until some processor comes and starts processing these messages. If talking about the size and the capacity of the channel, an unbuffered channel has a size of 0 and a capacity of 0 since it doesn't store any elements inside. But for a buffered channel, a size is the amount of the stored elements in the channel, and the capacity stands for the amount of the messages that the channel can store without blocking. About blocking, we're going to be talking more in depth when we get to coding. This is a simple example to demonstrate working with an unbuffered channel. As you can see here, we created a channel of integers. We passed a value to it. This syntax right here means that we are trying to send an element to the channel, and then we are trying to read the value from the channel. So if I run this code, as you can see, we got 1, which is the value that we have sent. Obviously, if we changed it, though, the value also does change. In this example, we used a Go routine to send the data to the channel, since this is an unbuffered channel, which means the sender expects that there's a receiver on the other side to process the message instantly. Now, here's an example of using a buffer channel. As you can see, we created a channel with a capacity of 1, which allows us to write to this channel despite there are no receivers to it yet. And then on a line below, we read the value, which gives us basically the value that we have already written. Now let's take one more example with channels. As you can see, this code right here creates a channel, an unbuffered channel, and then in another Go routine tries to send to this channel. Basically, we are sending runes. We are reading the message string and sending all the runes to this channel. And right here we are reading. As you can see, you can use the range statements, which you basically use with ranging with arrays or ranging in like a string literature. So we basically take all the messages that are being sent to the channel and we're appending them to the runes array. And right here, when the Go routine finishes reading the message and sending it to the channel, it closes the channel. Otherwise, this range statement will just block the flow of the application forever, because if a channel is not closed, the range statement or the for loop will never end. So if we actually try to run this code, we are basically getting the same string that we have already passed to the channel. Now, in the next example, we're going to demonstrate the behavior of a closed channel. As you can see right here, we created an unbuffered channel. In a Go routine, we are sending a single message and then closing the channel afterwards. Right here, as you can see, I'm reading, but there's an awk value that I'm reading from the channel, despite this is a channel of ints. But the thing is, reading of a channel always returns two values. The first thing is the value itself that has been sent, and OK is just a Boolean flag that shows or tells you whether this channel has been closed, because a closed channel always returns the default value. So if you run this code right here, you are getting 1 and true, 0 and false, because the value that has been sent was 1 and the channel was open. This value was being sent because the channel has received a message. But on the second case, the OK was false because the channel was closed. And in this case, the channel just returns the default value. And since this is a channel of integers, the default value was 0. In the next example, we're going to be seeing the behavior of a channel with a select statement. As you can see right here, we created two channels of string and then created two Go routines to write two different messages. The first one is hello and the second one is word. And before every write in the channel, we are making a sleep statement. And here in the select statement, we're expecting a message that's being sent from the channel. Also, when you're reading from the channel, you can also check this OK flag, but in our case, we don't need it, so we're not gonna actually use it. And if we run this code, obviously we're gonna get the hello message, since the time sleep here is 1 second, which is less than the one below. So this means we're gonna fall into this case. So if we run this code, we got a receive hello message. Right now, we have covered most of the scenarios with working with a channel in Go, but there's one more case that you are unlikely to encounter, but it's good to know. Who knows, it might come up in an interview, so let's take a look. So a channel can be nil, which means I didn't use the make statement to create this channel, I'm just using var. So basically this C right here is just nil, and reading from a nil channel always blocks the flow of the code. So if we run this code right here, we're actually just gonna get the done message, but we're not gonna get the hello word. Now let's take one more example with writing to a nil channel. As you can see right here, I'm creating a Go routine to try to read from this channel right here, and this time sleep statement is just to make sure that we have already reached this line right here in the Go routine. Then in the select statement, the first case is that I'm trying to write to this channel, and since there's already a receiver right here, it should work. But since this is a nil channel, actually this block is gonna freeze and this block is gonna freeze, everything is gonna be blocking. So if we run this code, you see the channel is listening, so we have went to this line of code, but this line of code didn't get executed, and we actually skipped this message and we printed done. The last but not least example is closing a nil channel. So as you can see right here, I've created a channel without make, so this is going to be nil, and then I'm trying to close it. So if we run this code right here, we actually get a panic that close of a nil channel. But if this channel has been initialized with make, for example, let's try to make chan init, then this code should work fine. Oops. And you can see it's just closing fine. Now to our last example, which is worker pool. A worker pool is one of the most popular patterns with Golang channels, and for this let's actually start with the illustration diagram. So the idea behind the worker pool pattern is that we can process multiple tasks in parallel and control the flow and the amount of the workers that are actually processing the message. So right here we have a task queue that is basically just some tasks that we want to get done. Let's assume in our case this is a messaging system, so we want to send, let's say, an SMS to the user and then store the message in the database and maybe notify other systems in our environment that this message has been sent. So right here the task queue is going to be containing the SMS messages that we want to send. We send it to the worker pool, and the worker pool has some workers. These workers are going to do, in our case, the following. They're going to send this message to the specific device, to the user, and then store it in the database. And in the output queue, they're gonna send a message or an acknowledgement that this message has been sent, and maybe some other services which is gonna read this output and do something with it. So this is basically what is a worker pool pattern. Now let's take a look on the code on how this is implemented in Go. So as we explained in the diagram, the main components of the worker pool pattern is the workers. So basically right here we're gonna be creating a new worker function which basically does the following. It takes an ID, which is the ID of the job that's gonna be processed, and the job channel, which is gonna be the channel of inputs. This is gonna be the task that we should get done, and just a wait group to notify the system that we have finished. Alright, this is mainly used in Go just to control the flow and safely, gracefully close the application. So basically this for loop here is just reading messages from the channel. This time sleep right here is just to simulate some work that we do with this message, and then we just print that we have finished working with it. So in the main function, as you can see, we're just creating some job, or creating the jobs channel, and right here we are initiating these workers. Each worker is going to be running in its own Go routine so that they can run in parallel, and then we start sending messages to these jobs. And finally we have to close the job, because when the job is closed, this for loop right here will terminate since the job is closed, so no more messages will be sent, and therefore we're going to be calling the wait group done message or wait group function, and then the waits function will execute and our code will actually finish. So let's actually try to run this with go run main.go, and you can see three workers have already start pressing the message, and then after a second, three, they took like three new jobs and they start also processing them, and so on. So this is actually a basic example of a worker group pattern. In the example, I actually showed you an output queue, but here's just a simple example. Instead of sending to a queue, we're just printing the results to the SD out. So this is all what I wanted to share about channels in Go. Right now we're going to go to the second part of this video, which is solving some interview questions. I highly recommend you first try to solve the problems by yourself and then take a look at the answer. So let's actually get started. Here's the first problem. You should answer what's going to be printed, and the solution is going to be in 3, 2, 1, boom. So the code right here actually has two bugs. The first bug is that we're not closing the channel right here, and this will cause the application to hang since the worker group dump function is not going to be called. So the fix is simple. After sending all the messages, we just close the channel afterwards. The second bug is that we're using range and we're sending the values from the range function to the channel, and this will cause that the output is going to be just 4 4s. But we just want to print 1, 2, 3, 4. And the fix is also kind of simple. You just create a new variable that's going to have the same value of value and then send this one. So now we go to the terminal. So now we just do go run and see it's printing the right values. Now let's get to the second problem. So as you can see, we have some channels and we are trying to write some values into them. We're calling the merge function that's going to merge the input of these channels into a single channel that we're going to be using to print the values right here. So your task is just to implement this merge function. So the solution is in 3, 2, 1, boom. So first we created an output channel that's going to be containing the messages from all other channels. We're going to loop these channels, and for every single channel of them we're going to be creating a go routine that's going to be reading messages from this channel and sending it to our output function. And once this channel has been closed, we're going to be calling defer done, and once all the channels are closed, this go routine right here will execute this line and therefore close the initial channel. Therefore this will actually close the channel right here in the for loop statements, and then after all the values have been printed. One more thing to actually pay attention to is this function has no order guarantee. So we're not guaranteed that the values are going to be printed in the same order, 1, 2, 3 or 1, 3, 2. So let's actually take a look on how this code does work. So let's do go run. We can see we got 1, 2, 3. If we run again, we got 1, 2, 3. If we run third time, 1, 2, 3. All right, 1, 2, 3 again, 1, 2, 3 again. See, yeah, this time we got 1, 3, 2. So this actually was kind of weird. We just got all these 1, 2, 3s, which is actually kind of unexpected, but you get what I mean. This is what is order not guaranteed. So let's actually get to the next problem. And here you have this code right here, and you should just answer what's going to be printed in this line. So the explanation in 1, 2, 3, boom. So first we just create a list of channels that has a single channel in it, and then we make a for loop that's gonna loop 10,000 times, and for every iteration we're gonna be appending a new channel into the list. And in this go routine right here, we're gonna be doing two things. The first thing is that we increment 1 to the message received in the current channel and pass it to the one before us, the one previous in the list. And this function right here, or this range statements, this for loop, once it terminates, only we close the previous one, channel. So right here, when we send the one to the last channel in the list, what happens is that we increment 1 and we send it to the previous channel in the list, and so on and so forth till it reaches the first element. So here we get 10,001, and when we close it, this actually is going to make this for loop right here finish or terminates, and then we're going to be calling the close function, and we're going to be closing the previous channel in the list, which will cause it will cause that the first channel in the list to be closed. So let's actually give it a try and run this code. So we do go run, and you see we get 10,001 and 0. So guys, this is all what I wanted to share with you about channels in Go. I really hope this video was helpful, and if it was, so don't forget to subscribe and give a thumb up. Thank you for watching, and see you on the next one.